Hi, my name is John Cross. I work with Varsity Tutors, and I'm going to chat about how we're using Presto to empower the school portion of our business. And some of you might be wondering, what is our business? Don't worry, I will get to that. So here's an overview of what I'm going to chat about the Varsity Tutors business model, talk about the problem that we're solving, look at alternatives that we used, that we explored, and how we ended up using Presto, specifically Ahana. So business overview, a little bit about Varsity Tutors. If you go to our website, varsitytutors.com, you'll see lots of more information. I'm an engineer, of course, not a marketer, but essentially we help students, parents, and schools meet their learning goals. And we have over 3,000 subjects level. We have academic subjects such as science, reading, math. We have test prep that could be anything from getting ready for a college exam or even professionals, ongoing certifications, enrichment, things like languages and music. Just going to hit next here. A growing part of this is tutors for schools. This is less than 3 years old, and we have types of ways that we help schools. We have on-demand tutoring. Let's say you are trying to get ready for an assignment, trying to get ready for a test. You need some last-minute help, even if it's in the middle of the night. If your school is using Varsity Tutors, then we can actually do chat, one-on-one chat, last minute, which could be helpful. And then we have two different programs. The first one that we started was actually high dosage, and that helps students that are at the bottom of the risk of not graduating, or they're at risk of not passing the grade. And these are kids that really need to get some extra help catching up. So high dosage, we say, we're going to give you X amount of hours, some good results from there. After starting the high dosage tutoring, we also did teacher assigned, and that is where teachers can ask for help for any student, not just a student who is falling behind. They will work with Varsity learning plan, and we can also get good results from that. So that's Varsity Tutors as a business. What does this have to do with Presto? I will describe the problem next. When we grew our business from primarily one-to-one tutoring, which could be a parent paying for a student, or in this case, a student might be an adult, the real outcome there is attending sessions, having fun learning, and focus between the students and the tutors. How that changed when we worked for schools, schools have a high reporting requirement. School districts want to know that schools are actually utilizing their tutoring. Teachers want to know if students are showing up to their sessions, and everyone wants to see if the students are progressing, especially if they're behind. Are they going to pass their next achievements? So pulling in a lot of reports to our solution was where Mike came in and helped. Yes.
John, I'm really sorry. Your slides are not advancing. We're still at the Varsity Tutors for School reporting.
Did the slide just change?
To alternatives explored.
Okay, awesome. So Tutors for Schools reporting, good.
I see the Varsity Tutors constraints.
Yep, so this is where I want to be, Varsity Tutors constraints. So backing up a bit, we're defining the problem. So the business problem was schools need reporting. Some of the technical constraints, we are an AWS shop, so whatever solution we chose needed to fit in nicely with everything that is running on AWS. We had a buy versus build decision, and we didn't want to throw too many new engineers at the problem. So that's where we looked at, buying something off the shelf versus building a whole bunch of software. All right, next slide. Alternatives explored, all within the AWS ecosystem. In this diagram, you will see a traditional ETL data flow. ETL, of course, being extract, transform, and load. There's a bunch of labels here, which probably won't make a lot of sense, so I'll just go over them at a high level. On the left side, there are some databases. So these are source databases. There's a big database disk on the right-hand side, and that is the target database. Orgs, in case anyone stands for organizations. That's what we treat our school part of our business, doing business with schools being a type of an organization. So the square box in the middle is DMS. That is database. It's an AWS service that will essentially replicate data from a source to a target. So this probably looks familiar to a lot of folks that have done ETL and reporting solutions. This is what we initially went with. We're using DMS to replicate data from a number of different sources into a single database. So we have data copied, and then we're doing a second step to transform that data into reporting tables. So I will go through what we liked about that and what we were trying to improve. Next slide. First of all, using the DMS approach, there's a lot of moving parts. Data is getting copied multiple times. In order to be in the final reporting database, we have to copy it from several different sources, and then we have to build a reporting table. Now, building that reporting table in the reporting database for schools is not necessarily going to be the same as building it in other places, such as internal reporting. So decentralized business logic which is not a new problem. Anytime someone deals with a lot of reports, quite often the question comes up, hey, why is this report different in this place than it is where I saw it yesterday? In addition, I'm just going to go back. Looking at the orgs database, the reason why I drew it larger than the other databases is it has a lot of load on it. Yes, it has lots of data, but it also has a lot of load. So there was potential concern as we grew our organizational part of the business. We want to overwhelm the transactional database with this analytical load. So we started looking at different solutions. The first solution that we looked at was Athena because it's an AWS service. Picked a couple different queries, did some benchmarks, and it wasn't too bad in terms of execution time. Sometimes it was twice. The problem was we ran out of memory. And there was no fix for that because Athena, even though it uses Presto under the hood, it wasn't able to scale. We didn't have any options. We couldn't say use a bigger Athena cluster for that was pretty much a non-starter. Next, we looked at Redshift. Redshift had similar performance. It was about twice as slow as the standard in the, which wasn't too bad. But some of the concerns around Redshift, if folks are using Redshift, you're probably familiar that sometimes a query will take 1 minute, sometimes it takes 10 minutes, depending on how your cluster is. And a lot of that is dependent on queue time. So there was concern over external users coming in, asking for a report, and waiting 10 minutes. Of course, that would not be a good experience for external users, let alone. So that was a big problem with using Redshift. Additionally, to share some of our architecture with you, we're mostly using Redshift for internal reporting users. So to stand it up and have it available for schools would have been a lot of work. So finally, we chose to use Presto, and I'll get why we chose it and what that solution looks like. Specifically, we chose to use Ahana within Presto because it's a managed solution. And as I mentioned, we had a buy versus build decision, and it was going to cost less engineering resources to use a paid service, which is Ahana. All right, so here's what the new diagram looks like for data flow. We still have the same sources on the left, several different databases, but now instead of using DMS into the target database, which is over on the right, that's the orgs database. Notice how that's a smaller database. There's a lot less data going in there because we're no longer copying all the information we need to build reports. Instead, we have them as data sources inside the Federated query engine. And then we have the ETL job, so the transformation is happening within Ahana, doing the Federated query, and we're writing those results to S3. Lambda, running inside AWS, that picks up the results and writes them into a neat little set of reporting tables for the final database. All right, some of the considerations. Why did we pick Presto? Scalability. That means both in terms of meeting the benchmark, which was around a minute, when we wanted to create a report, as well as not running out of memory. So we had good ability for scaling out the Presto cluster as large as we needed to meet the SLA without having costs. Also running it on its own service in its own AWS account, which I'll get to in a minute, gave us a nice level of abstraction. As I mentioned, we're using Redshift currently mostly for internal reports. I have a system that was dedicated to our external partners, which would be the schools and the school districts. Folks that use Presto know that it's really geared towards merge. It's really geared towards inserts. It's not meant to be an ETL tool per se, so it can't really do updates, but we do have a workaround about that I'll describe. And because we used a paid solution that other folks had access in its own account to meet some security considerations. So we'll chat about that a bit as well. Overlaying security on the previous diagram, we've got 3 different AWS environments here, each color-coded at a high level. So the light blue on the left, we have all of our source data, all of our super sensitive information locked away in a secure account, and it stays in that account. The only time data leaves that account is we have our Ahana cluster running in its own account. That's the red box in the middle. And the results of the federated queries get shipped over to a third account. That's on the right. That's a dark blue into an S3 bucket. So high level, the Presto cluster is running in its own account. Neither the source data stays in that account, nor the target data coming out of the federated queries stays in that account. So we were pretty happy that we were able to isolate the security and to chat about some of the ways we did that. There's some links at the end, but high level, there's fairly good documentation around VPC peering. That setup wasn't too hard. And so VPC peering was involved, moving from the source data into the federated query engine, and then writing to S3. This is a cross-account write, and folks that work in AWS know that anything cross-account can be a little bit tricky, even something as simple as S3, but we were able to get that working using AWS documentation, as well as changing a config setting in Presto, which unfortunately was not available through the console. So we couldn't use a simple, the GUI, we couldn't use the log on a console to change it, but it was a simple config map change on the back end. I will, at risk of repeating best practices, for us, security-wise, it was a best practice to install Presto in a separate AWS account that did not retain any data. Another best practice for us, and this gets back to having business logic spread over, is we moved as much business logic as possible upstream to the source databases. So instead of having, let's say, 1,000-line query in Presto that's really complicated, that was reduced to, let's say, a 100-line query in Presto. And we're using S3 to hold snapshots, and the workaround for that is we have lambdas that are picking up the data, and that lambda is triggered by an AWS event when Presto writes the data. It does a merge insert into the final reporting database. So we'll chat about that just a little bit more. Next slide. So these are some not really code examples, high level, let's call it pseudocode examples. So the first of all, in order to enable the cross-account S3 write, for anyone who cares about the details, this is what the config map setting needed to be. ACLs to the bucket owner full control. Next up was we created a schema. This is in Presto, created a schema so that we could write to S3. And the last little sample here is, again, this is all within Presto. When we create a table which writes to S3, we're doing the with format CSV. And the reason why we're using CSV, I will go to the next slide, is because we wanted to have the ability for the target database, which is an AWS RDS database, to load directly. In other words, not to have to stream it in a bunch of statements. So that helps both for scaling up memory requirements, as well as it's just a lot faster to do it this way. So what we did for the target database, again, we had that triggers off an S3 event. And then we had a template so that we can scale this to a whole bunch of different tables. And the template essentially creates a temporary table. It uses the S3 table import to load that data into the temp table from S3. And then again, this is part of our template. We essentially do an upsert. So the merge happens to be an update or an insert, depending on what the data looks like. All right, that is my presentation. And while we're waiting for Q&A, I'll just leave this slide up with some links. And just to describe the links, the first link is varsitytutors.com. And the next link, Nerdy, that is our parent company. About Nerdy versus Varsity Tutors, I encourage you to click those links and see the relationship. And the last two links are about the setup that we use for cross-account. First one from Ahana for VPC peering, and the last one from AWS, the ACLs, the access control lists, working correctly to do the cross-account write and read from S3. Thanks, everyone.